Hi, I'm Jonathan Amy, and I'm here today with Clay Starlin, who is graciously going to talk to us again. And today he's going to be talking about educational units of measurement. So, Clay, take it away, buddy.
Okay, thank you, Jonathan. So welcome to presentation on educational units of measurement. To obtain a complete picture of student performance, we need to consider three parameters of performance: the level of performance, the trend of performance, and the variability performance. So we need to use three different units of measurement to monitor changes in level, trend, and variability. The first is frequency. So frequency is the level of performance measure. Performance always involves a number of responses and always occurs over time. So responses per unit of time, or frequency, is the most sensitive measure of the level of performance. So we compute frequencies by getting a count. If it's an academic area, we look at correct and incorrect responses. If it's a personal social area, we look at desired and undesired responses. We time the duration of performance, usually in minutes in instructional settings, and then we compute the performance frequency, so count over time or minute. So here's an example of a number of different counts and a number of different time durations. So it's just a matter of doing the division to see the count per minute. We always want to have a standard unit. So if we observe over different time periods, then the data is comparable from one observation to the next. So frequency is the most sensitive level of performance measure because it is complete and direct measure. Non-frequency measures are less sensitive because they're incomplete or indirect. So a couple examples. Here's Maria, who read orally 150 words correct on Thursday and 75 words correct on Friday. But her time of reading was 3 minutes on Thursday and 1 minute on Friday. So if you look at the words per minute, she actually read more words per minute on Friday than on Thursday. And here's Andrew, who had 10 tasks completed on Monday and 20 tasks completed on Friday. But he was 5 minutes on task Monday and 20 minutes on task Friday. So his tasks per minute were 2 on Monday and only 1 on Friday. So that emphasizes the importance of complete information, both count and time. There are quite a few measures in education that only use count or time, such as time on task or number done. So we lose some important information in terms of informing our decision making when we don't have a complete information of count and time. So here's an example of direct versus indirect measures comparing frequency to percent correct. So here are 10 different students who, out of 131, 7th grade students who read a 7th grade literature passage. This is an oral reading scores. Now we convert those scores into percent correct. We have 10 different scores here, but only 3 here, 100, 99, and 98. So this is an example of the sensitivity issue. So only have 3 different scores here, but we actually have 10 different scores here. So the frequency measures are actually 3 times more sensitive in this example. Another important variable is if you take someone like Lynn, who's reading 82 and 0, if she starts to read like Doug at 22, 23 and 0, if you live in the percent world, you would not see that change because she'd still be at 100%. So another important aspect of making sure that we have maximum information to inform our decision making. So precise performance measurement involves directly observing and counting over time what we see and hear students do. And frequency is pivotal because the decision regarding our base performance measure determines how we measure the trend and variability of performance. Another important aspect of frequency is a measure that's used in all natural sciences. So by education adopting frequency, we get in line with other sciences. So the next measure that we're interested in is learning slope, which is the measure of the trend of performance. So learning slope equals the trend of performance frequencies over time. In instructional settings, that's usually computed per week. So technical term for learning slope is acceleration. And you can see the root of both acceleration and deceleration is acceleration. So an increase in the slope of frequencies per week is acceleration, and a decrease in the slope of frequencies per week is deceleration. It usually requires from 5 to 11 data points to determine a learning slope. And we draw a line of best fit through data on a standard learning chart. There will be a future video explaining the standard learning chart. But as you see on this example, the dots represent correct performance, which is accelerating, and the X's represent incorrect performance, which is decelerating. We use what we call a learning slope reader to find the value of those acceleration or deceleration slopes. There is a tool that includes a slope reader called Easy Charter, which is available from Behavior Research Company. This is what we call acceleration or learning slope fan, which was developed by Dr. Ogden Lindsley. And if we look at the slope of these two pictures, the correct performance is right at ×2 or doubling, and the incorrect performance is declining by ×2 or dividing by 2. And so this is an example of performance increasing as doubling and decreasing as halving. If the performance doesn't change, that would be ×1. So if we multiply something by 1, it doesn't change. So the steeper the acceleration or deceleration slope, the more rapid the learning, the slower the slope, or the shallower the slope, the slower the learning. So this is kind of a way to kind of put the learning information and the frequency information together. So learning equals the change in the trend of frequencies. Frequency is count over time or count per minute. We measure count by counting, and that gives us accuracy, the number of correct and incorrect. And we measure time by timing, which gives us the pace or total number of responses per unit of time. The third variable that we are interested in terms of a measure is bounce. So that's the measure for the variability of performance. The classic learning sequence, we have an accuracy phase with significant bounce in both correct and error performance. We have kind of a pace building phase where bounce tends to reduce oftentimes in both correct and incorrect. And then a mastery or rhythm phase where this performance is smooth and there's no significant bounce. Large bounces performance is often disruptive to a student and their classmates. Significant bounce is characteristic of students who have descriptions such as attention deficit disorder or autistic or emotionally disturbed. We make bounce visible by depicting it on the standard learning chart, and we calculate the bounce based on how much the data vary above and below the learning slope line. So here's the learning slope line. Here's the highest frequency and the lowest frequency. We ignore the outlier information. So what we're calculating is the distance from this lowest frequency to this highest frequency, and that's what we consider the bounce. So here's an example of bounce that is accelerating, and it's a fairly small bounce. And here's an accelerating picture with larger bounce, and here's an outlier here. And then here's a decelerating picture with kind of bounce that's in between. So here's kind of a summary of that information of the parameters of level, trend, and variability, and the measures that measure each of those and how we calculate those. So through the educational units of measurement, frequency, learning, slope, and bounce, we gain a complete picture of student performance. The sensitivity of these metrics makes information visible that is hidden with less precise measures like letter grades or percent correct. We see the differences in lower versus higher frequency performers, that's frequency, or slower versus faster learners, that's learning slope, and students with more or less performance variability, that's bounce. So this information enables us to determine the differential effects of our interventions leading to improved decision making. So that's finishes the presentation. Thank you for watching. If you're interested in additional information, here's some contact information.
Well, Clay, thank you again so much for these videos. This is really terrific. I learned a lot about bounce, and so thank you so much for that, Clay.
Welcome. Thank you.
And hey, we got you on recording too, that you're going to do another video for us. So said you were going to do another video.
I didn't say me. I said a future.
Well, we'll
that
see.
could be anybody.
Thanks, Clay. I appreciate it. Thank you.